Assalamualaikum warahmatullahi wabarakatuh. Today we are going to learn about exponentials. I bet all of you already know what is exponential because you have learned it during your secondary school. However, today we are going to recall a little bit about this topic, and later on we are going to relate it with chemistry. Okay, now let's look at this formula where we have y equals a to the power of x. A is a constant, x is the control variable, and y is the observed variable. Just imagine if we have the rate of reaction as the temperature increases. That means x will be the temperature, y will be the rate of reaction. If you look at this graph, it shows the rate of increase of the temperature, the rate of increase of the reaction as the temperature increase. So I have a question here. Can you guess what will be the coordinate at the point that I've highlighted here? Please discuss with your friends. Okay, I will give you about 2 minutes. Then I will ask you what is the answer. Okay. Okay, thanks for the commitment given. Okay, this is just to explain what you have discussed just now. Okay, let's assume this graph is y equals to the power of x. Okay, so we can see the graph increases at a very fast rate, which is what we'll expect with exponential growth. Okay, at this point, the coordinate will be 0, 1 because a to the power of 0 will give 1. Okay, so that's why we will have 0, 1 as the coordinate here. Another tip that you need to know is the value of I are small and positive when x is negative. Y are large and positive when x is positive. You can try, put any value. For example, you put y equals 2 to the power of negative x, and then make a table and put any values. For example, x equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you find the value of y. You will see you will get a different graph as compared to the graph that we have discussed here. Okay, previously we have learned about pi, where pi is equal to 3.1415926. In this topic, exponential is equal to 2.7182818. So we have a value here, we have a constant here. Okay, in other words, we replace a with exponential, then we will get y equals exponential to the power of x, or we can also state like this, exponential in bracket x. Now we will look at the chemistry example. Given with this equation, k equals a exponential to the power of negative EA minus RT, where EA is the activation energy, R is the gas constant, T is the temperature. So all values are given here. So you just need to plug in the value. Finally, you will get this value. Remember to use exponential in your calculator as E. Okay. Now we have two types of exponential graph, where the first one shows the growth of the process. This one shows the decay of the process. How can we get this graph? This is due to this equation, where y equals exponential to the power of x will give this graph, and y equals exponential to the power of negative x will give this graph. So this is the algebraic rules for exponentials, where this is some sort like index rule. Okay, here if you can see, we have a to the power of x times a to the power of y equals a to the power of x plus y, because we have the same constant here. Okay, the same goes to number 2 rule and also number 3. Okay, for number 2, if division, we need to minus the power. If product, we need to times the power. Now the question is, can we use this rule to this equation? The answer is no, because they have a different constant here. This one is exponential, this one is 3, this one is 4. Okay, so we cannot use this rule.